Controls, off the tower, Raptor 352, Tango Delta, holding short of 35, ready for departure.
Raptor 352, Tango Delta, now off the tower, runway 35, clear for takeoff.
Runway 35, clear for takeoff, 352, Tango Delta.
Welcome back. So this is the second flight for the day, and obviously a little bit later in the afternoon now. So this is the first time I've taken the aircraft up twice in one day. And a couple of things I'm monitoring is just, starting off with an engine that's not completely cold. It hadn't, fully cooled down, so I'm just sort of mindful of that and just seeing how that affects things with respect to temperatures. And what I wanted to do on this particular flight was just sort of set the cruise power here to around about 75% throttle once I was up. And on the previous flight I had it at 68% throttle, and that was keeping the temperatures really well within spec there. I think it was 229 on the oil and 190 or something on the cooling, which is well in the thermostat range. So this one I wanted to just push it a little bit further and just see how that affected things. And of course the ambient temperature now was about 10 degrees warmer later in the day, so that was going to affect things. So anyway, I just wanted to get a comparison of that. And also I had retaped that inlet floor flap again there, and this time with some 3 layers of that metal foil tape to see if that would hold it. And ultimately you'll see here, if you look carefully a little bit later in the flight, you can actually see it moving around again, and by the end of the flight it had come loose again and was flapping around. But knowing what it was, I wasn't too concerned, but I ended up sort of ending the flight there about 30 minutes in. So yeah, that was the goal for this flight. So just pushing things just a little bit harder. I just want to find out exactly what the most comfortable power settings are that I can do right now with the cooling that I have to get the best performance out of it. And on yesterday's video, some people had commented that they actually prefer not having the radio transmissions on there. So probably what I'm going to do now is I'll edit out most of it and just have my communications with the tower, for context, so you kind of know what's going on, and then keep the rest of it to a minimum. It's a little bit more work for me to do that, but I think the outcome is better. And this particular flight, I didn't actually bother putting a camera there on the radiator setup. Pretty much know what that's doing. Where it was stable at about 195 over 180 something on the last flight, that's basically means it's right on the thermostat there. So it's doing exactly what it's supposed to do to keep the temperatures around about 190. So there's probably a little bit more in there, in that I can run the engine at a higher power setting and those temperatures will run a little bit higher, but they're not going to go any lower than that when I'm cruising along, because the thermostat's holding it there. So even though it was only holding a delta of about 6 degrees, that's because the thermostat's basically doing that. Otherwise it'd be flowing more coolant through there, which would have been dropping the temperatures some more, I believe. Either way, being a prototype and all, you find out exactly where your limitations are, and it looks like the aircraft could benefit from having a larger radiator setup. So that's something that we'll be doing with respect to moving forward for production, is just configuring things on the inlet there to allow a larger radiator core there, or potentially doing something else with an oil cooler, another additional oil cooler that's working better. I'm actually going to hook up my thermometer probes there to that oil cooler in the back. I'll do that coming up, over the next couple of weeks or couple of flights, and then we'll be able to see how well that one's doing with respect to cooling the oil that's returning from the redrive. And as you can see here, I'm climbing at a reasonable rate here. I've got the engine set to 75%, seeing about 15 gallons an hour burning there. And it's definitely not performing quite as well as it did early, because the temperature, I think the ambient temperature actually gone up probably more like 20 degrees, because I think it was mid 40s in the morning flight, and then at least up at sort of 3,000 feet. And on this particular flight, it was already up at 60 degrees or more, 65 degrees. Ended up being a nice afternoon. So yeah, you can definitely see the difference in performance. But the good news is, with that thermostat thing now sorted out and working nicely, and with the new openings there on the cowling, I'm able to climb 75% throttle there, and with the prop around about sort of 3,000, or sorry, the engine at 3,100 or 3,200, or even back at 2,900, and the temperatures stay in check. Keep the oil temperature around about 245 maximum for the climb, and I think that's completely reasonable for this engine. I've had it as high as 265 and didn't have any issues with it, but I would never run it there for long periods of time. Most of the understanding that I get about this engine is that if you're in a car or whatever you're towing, you would run it 240 to 250 for towing, but then you wouldn't want to get it any hotter than that, and you'd want to let it cool down after sort of a reasonable tow up a hill or something like that. And that's pretty much what I'm doing here. I'm keeping it to 245 in the climb, and then when I get up to altitude, I'm powering back enough and speeding up enough that you want the temperature to come down to around about 235 maximum. Ideally 230. Now it'd be interesting to see when I get it up to higher altitudes where the air is colder. I don't think it'll be too much of a problem at all to be cruising, with sort of 75% power, and have it, keeping the temperature around about 230 degrees on the oil, and the coolant would be, be 195, where the thermostat will hold it. So yeah, that should work out. And if I get up there and I can see that that's what's happening, then it's basically almost proven that, okay, I need more radiator for down low, but up top I'm fine, So anyway, that's kind of things, and I'm just slowly working forward on this, just making the improvements, and then one change at a time type thing, and obviously documenting all this in so many different ways, including all this video which shows exactly what's going on, so you can always go and look back in detail and see exactly how any particular flight was performing. And I'm keeping all the engine logs from the Motec ECU, so, and with that ability that you've seen before to overlay one flight on another, you can easily see where performance gains have been made. And I'm trying to fly a very similar profile on all those flights where I'm climbing out, so it's really easy to compare one flight data to the next in terms of the power settings that I'm using for climbing out, which just really goes to show, or at least tells you whether something you did made a difference or it didn't make a difference, or if it was negative or whatever. So I mean, having all that logging information is just invaluable. I'm actually look back now, I remember when I was working with the the guy who was the tuner that I brought on board, and he was sort of, you know, throwing around ideas on which ECU to get to run the engine, because, you know, we couldn't just run the Audi one because we didn't have any control over doing anything, and it you know, was designed to run the car, so we couldn't run that. And anyway, when he made the decision to use the Motec one, you know, really that was a great decision, because I don't think any of the other ECUs out there have you know, quite so much ability for, you know, logging and being able to change things. So it worked out really well having that ECU, and it's allowed me to, you know, tune the engine and monitor everything, and just it's really given the capability that was necessary. So here I skipped forward a little bit in the video on the last part of the climb here, and now I'm kind of at the maximum altitude. And if you can see there, really, if you look really carefully there in front of the intake scoop, you can just see that thing flapping around up and down again, so it's come loose again. And so at this point I was just like, well, I think I've got enough data here of what how the engine was performing with 75% throttle, so I'll call it a flight and head back in. But if you see there, I was like pretty close to the airport here, and you know, pretty high still. So I figured I would just basically make one more left-hand circuit and get myself a little bit further away from the airport. There you can just see it's, you know, going below me right there. So I figured I'd make one circuit and start my descent already, so you know, I didn't have to bomb it in from 4,600 feet. But it's fun actually doing those arrivals like that. And it's the one thing that you don't get to do when you're at a uncontrolled field. You don't really want to be doing these bomb-in approaches, but, you know, if you're at a towered field and they're okay with you, you know, being, you know, up above the airport there, and they clear you for an approach like that, then everything's all good. There you can see the runway there below me. So yeah, I'm just going to make a left turn here and then get myself a little bit further away and then make the call. So yeah, I got that new static port coming next week, the used Piper one, and get that mounted below. And I'm pretty sure that that one is going to be something that potentially was dialed in as well by them, because it has the static port on the back of the mast of the blade, and then so the feed from that comes in from the top and it goes down, and then the static port goes directly backwards out the rear side of the blade, and then the feed also continues down to a drain hole that comes out the bottom, and the bottom of that blade is angled. So my understanding is that potentially that drain hole there coming out the bottom of the blade on an angle. Now the air is going to be running past that drain hole there, which is, you know, sloped downward. So is the air going to be pulling out of that hole, like creating a vacuum as it runs past that hole on an angle, or because it's sort of facing into it, is it going to be pushing up in there and holding pressure on there? Either way, it's going to be doing something in there, and I bet you that they dialed that in. That angle was probably very specific in order to, you know, not affect the static reading, you know, and create an error on there. So I'll be mounting it there where you see the antennas are. That's where my static port is right now, and that's going to be pretty close to vertical, the way it'll be mounted. So hopefully get a decent reading off of that. And, you know, if not, I'll have to try something else. The way I've been making the changes to the current static port with this little fence on there has actually been improving every time. I'm getting much closer to having accurate readings there, at least with the airspeed. The altitude, it's difficult to know whether I've got correct altitudes and stuff, because the GPS doesn't seem to give, you know, great accuracy on the altitudes. But the airspeeds are getting closer because my ground speeds are matching up much better with respect to the winds at altitude when I'm heading one direction or the other.
Well, that's the tower at the 352 Tango Delta is about 3 to the northeast at 4,400. Like to come in for a full stop landing.
Flash call with Boston Tower, clear.
Raptor 352 Tango Delta is about 3 to the northeast at 4,400 feet. Would like to come in full stop landing.
Raptor 352 Tango Delta, enter right base for runway 35, report 3 mile right base.
We'll enter right base for runway 35 and report 3 mile for 35, 352 Tango Delta.
Raptor 2 Tango Delta, radar com, altimeter 3005.
3005, 2 Tango Delta.
And I got myself in a much better position now where I'm just further away from the airport, as you can see, and 4,000 feet, so this will be just a nice cruisy approach in there. Again, just keeping my airspeed, well, I don't want to extend the gear until my airspeed's around about 125. So, you know, I've been extending the gear, you know, right before I make my base turn normally, and that works out pretty well because, you know, you've got to start bringing the prop back in, which, you know, speeds up the engine a little bit, and, you know, I want to do that carefully. I don't want to be driving the engine too hard with the prop. It's not necessary to do that, but it slows down the aircraft. Definitely just pull the power back a little bit and slowly start bringing the prop forward to the flat pitch setting, and you see my airspeed's coming down there. So you actually have pretty good control of your airspeeds there in descent. So you see it coming down there at 500 feet a minute and easily being able to maintain, you know, 130 knots there, and got the power back there at about quarter throttle, 6 gallons an hour. So yeah, and once you get the gear down, then you've really got to bring your power back in if you want to just sort of cruise around.
Raptor 2 Tango Delta, runway 35, clear to land.
Runway 35, clear to land, 2 Tango Delta.
And so once I got the gear down there, I'll pretty much keep it around about, you know, in the 115 knot range. You know, I could be at 120 if I wanted to. I'd probably be fine at 130. But anyway, so that's where I keep it at there, and approach seems to be nice, around about 115 on base, turning to final seems to be comfortable, and you know, when you hit the bumps and stuff, you know, you get bumped around a little bit, but in terms of controllability, it doesn't feel like the aircraft is sloppy at all. There's definitely loads of authority with respect to, you know, pitch and roll. So you know, I think that's the comfortable speed, and then, you know, coming over the threshold there at around about 105 seems to be the best, and touching down, you know, if the gear touches down at about 90 knots, indicated that seems to be the best as well. You know, I've had it touch down as low as 82 knots, and, you know, still not have a crazy nose pitch up attitude. But it seems to be more comfortable at 90 knots, just sort of flying it on there. So that's what I'm going to keep doing, I think. And stay tuned after I touch down here, and I'll show you just a real quick recap of the engine logs, so we can see how that compared to the previous flight. Alright, let's take a quick look at the engine logs just to see how that flight turned out. Alright, so I've gone and overlaid the earlier flight over this current flight, and that's the one in white. So all of those ones in white are the ones from the flight earlier in the day, and you can see the differences there. I mean, basically flying exactly the same profile there, pretty much, in terms of, you know, my throttle position and fuel flow, well, fuel flow sort of, and the and where I'm setting the prop, or so the engine RPM. And the difference is here, you know, right about here where on the previous flight I put the power or the throttle back to 68%, and on this one I kept it at 75%, so that was what the goal was there, to see what a difference that made. And you can see pretty clearly there what the difference it made on the oil temperature. So just kept the oil temperature higher there, 241, 242, 243, I'm reading over here, 245, and again, you know, climbing up, and I think I went to slightly higher altitudes this time, so going slower, and that actually ends up, you know, keeping things a bit warmer as well. But ultimately, you know, when I leveled off there at sort of, you know, 4,500 feet with the same power setting, so actually, oh no, I dropped it down a little bit, 71% there, so I did drop it a little bit just to see where it would bring the temperatures down again. So obviously 75% there is basically to keep it around 245. And then if I bring it down a little bit below that, 73%, 72 there, 71, then it starts to come down again. So, and it was sort of responding similarly to the previous one. So there at 67% when I was starting the descent. You can see it's coming back down to where it was before, and that's basically where it would have stabilized. Although I think it would have been a little bit higher because the ambient temperature outside was a little bit higher. And you can see where I started off the flights there, what the ambient temperatures there were, 46 on the morning flight and 68. So it was 24 degrees warmer pretty much in the afternoon flight. So that, you know, made a difference there, and as you'd expect. So anyway, it's good now that at least, you know, that I have the cooling under control, and I can see these temperatures in here, you know, 199, 189 for coolant, and that's where it should be. So, you know, the thermostat's trying to keep it to 185, and if I had a little bit more radiator in there, I'd be able to run higher power settings. But for the most part, you know, I think I've got everything out of it that I can with the current configuration. So anyway, that's pretty much the this flight. Obviously, the white ones go along longer there because it was a much longer flight. But anyway, that's going to be this video. I'll be putting out another one tomorrow, which is going to be exciting, so don't miss that one. Anyway, thanks for watching, and tune in again tomorrow for the next one, and we'll see you then. Cheers.